Question number 7. This question is about elements. Cesium is in group 1 of the periodic table, so it is a metal. Sample 1. It is an AO1 question from the topic of group 1 elements and ionic compounds. Explain what happens to cesium atoms as to oxygen atoms when cesium reacts with oxygen to produce cesium oxide. You should answer in the terms of electrons. It's a 4-mark question. The student needs to mention about the electrons and the ions in their answer. Cesium belongs to group number 1, so it has 1 electron in its outermost shell. It loses 1 electron to oxygen and become positive ion, whereas oxygen gains 1 electron and become negative ion. As a result, a force of attraction develops between cesium atom and oxygen atom on losing and gaining of electrons. Therefore, a bond is formed between them, that is an ionic bond. Let's see the model answer. Cesium will lose 1 electron from its outermost shell and become cesium plus 1, mean the positive ion. Oxygen will take 2 electrons, 1 electron from each cesium atom. So it means we need 2 cesium atoms, and oxygen will become O2 minus or oxide ion, a negative ion. 2 cesium atoms react with 1 oxygen atom and form cesium oxide to full outermost shell to become stable like noble gases. Sample 2 is a combination of AO1 question and AO2 question. Explain why cesium is more reactive than sodium. You should answer in terms of electron. If you see here, sodium, potassium, rubidium, and cesium, these are the elements of group number 1. Sodium is higher in the group, whereas cesium is lower in the group. As we go from top to the bottom, the size of the atom will increase. The outermost shell is away from the nucleus. Therefore, the force of attraction between the nucleus and the outermost shell will reduce. Therefore, cesium can easily lose electron as compared to sodium. Therefore, cesium is more reactive than sodium. Let's see the model answer. This is an AO2 part, meaning the student need to apply the knowledge, and the knowledge coming from this point. Cesium is below in group 1 than sodium. You can see here group number 1 element, cesium is below than group number 1, sodium, and has more shells than sodium. The outermost shell of cesium is far away from nucleus as compared to sodium. It means it has more shells, therefore the outermost shell is away from the nucleus as compared to the sodium. The force of attraction between the nucleus and the outermost shell is weaker in cesium than sodium. So it has more shell, the outermost shell is far away, therefore force of attraction is quite less as compared to sodium. Therefore, cesium will lose electron more easily from its outermost shell as compared to sodium. 7.3 is a combination of AO1 and AO2 question. This is figure number 6, a part of the periodic table. This periodic table is showing the Mendeleev's periodic table. We can see that the elements are arranged in the form of columns. Explain why the early periodic table placed iodine before trillium, but then Mendeleev placed trillium before iodine. The student must know that Mendeleev arranged the table according to increase of their atomic weight. Students should not write the word atomic mass. There was no concept of atomic mass at that time. If you see here, 16 is here, 19 is heavier, 32, 35.5, 79 and 80. But in this case, we can see that 128 is coming before and iodine has 127. In figure number 6, we can see that Mendeleev violated his own rule. He arranged the elements according to increasing of their atomic weight. Trillium is heavier than iodine. Iodine must come before trillium and trillium come after iodine. We can see there trillium is coming before than iodine. The reason is trillium has similar chemical property to these elements, whereas iodine has similar properties of these elements. Therefore, Mendeleev arranged iodine after trillium. Let's see the model answer. The early periodic table were arranged according to increasing order of their atomic weight. It is a key word. Don't write the word atomic mass because at that time there was no concept of atomic mass and student will lose 1 mark on writing the word atomic mass. Figure number 6 shows that iodine 127 has lower atomic weight than trillium, which is very obvious. But Mendeleev placed iodine after trillium because iodine has similar properties to the elements in the group. Means iodine has similar properties to the elements in its group, whereas trillium has the properties similar to this group.